Hi. Having kind of a bit technical sessions after lunch is perfect. So please bear with us because this sequencing thing is kind of a really important issue in this area. So it's really a pleasure to have you all. Charles from Espresso and Lisa from Aztec. So
very happy to be here.
Okay. Before we getting started, would you briefly explain your company and what you are building at this space?
Sure. Hi, everyone. I'm Lisa. I'm the CEO at Aztec, and we're building an encrypted ZK rollup on Ethereum. And what's unique about our approach is that we're enabling both private and public transactions. So for applications that require encryption, developers can build that on Aztec.
Do you want to maybe explain what the relevance is to sequencing?
Yes, of course. So as a rollup, which we'll get into, we are thinking about decentralizing our sequencer at mainnet launch. And so as part of that, we've been having conversations with folks in our community, in addition to folks like Espresso who have expertise in this area that will help us think through what are the different trade-offs and implications for decentralizing the sequencer and how should we design it so that it addresses our goals.
Cool, and I'm Charles. I'm one of the co-founders of Espresso Systems. We are the lead developers of the Espresso sequencer. And what we are building is a decentralized shared sequencer. So decentralized means that the sequencer is run by many nodes. I'm sure we'll talk about that more. And shared means that many rollups can use the same infrastructure, and there are various benefits from that as well. Espresso, the sequencer, is built on a consensus protocol that we've developed called Hotshot, which is a decentralized proof-of-stake version of a protocol called HotStuff2 by Dalia Malki and team. And it's got a lot of cool properties like optimistic responsiveness that I'm sure we'll talk about as well. So yeah, very, very happy to be here.
So, this is AJ from, I'm a founder of Radius. I'll be doing moderator and panel both. So Radius is building a shared sequencing layer for rollups to enhance rollup-centric Ethereum. We believe that rollup should be kind of type that all developers should choose when building a dApps, because rollups has flexibility and scalability compared to smart contracts. So the sequencing layer that Radius is building is help developers to make this deployment of rollups kind of easy. So we want to contribute to this space, especially to enhance rollups and through Ethereum. So kind of awkward that I will ask questions, and then I will answer to that question that I asked. So before we getting into the topic that about sequencers, I'd like to ask you that actually we had a lot to think about when trying to differentiate our product in the market when we started. So other than the topic about the sequencers, what kind of unique problems have Espresso and Aztec been trying to solve?
So for us, as I mentioned, we are unique in that we are focused on supporting both private and public transactions. So as folks in this room know, there's many rollups that are focused on scaling Ethereum, which is obviously one of the biggest challenges. The other is privacy. So scaling and privacy are in our view, the two biggest challenges with Ethereum, and we're tackling both. That it introduces unique both technical challenges as well as challenges in terms of how we think about decentralizing and like what our priorities are. So for other rollups that are focused on high throughput, low latency, they would make different design decisions than us, where we're focused on enabling these private transactions, and we are prioritizing things like geographic diversification and liveness. So it just means that we have a different way of looking at solving this challenge.
Yeah, great response. And totally agree that the design space of rollups and sequencing is super big. But maybe to give a good response on the value proposition of Espresso, maybe it's helpful to go over how rollups currently work. So the general design behind rollups, and this is a broad generalization, is it's a scalability method to take thousands, tens of thousands, millions of transactions, and to batch them together into a single state update, and then to present that along with a proof that the state update, the execution is correct to some verifier, which could be an L1. And right now, when a user interacts with a rollup, the user submits a transaction generally to a central server. So all of these rollups, whether it's a general purpose rollup like Optimism or Arbitrum, or it's an app-specific rollup like an NFT or a gaming rollup, users submit to a central server that is usually run by the rollup operators, and that rollup operator is responsible for everything, including the ordering and the execution and the proving behind that transaction. And when I say proving, that applies to both optimistic and ZK rollups. So optimistic rollups, they assume that the transaction is valid, but then users can submit fraud proofs in case something finds something wrong. ZK rollup, they use a cryptographic guarantee. But anyways, the fact that a single server is controlling the entire process is very dangerous. So first of all, one problem is that there's a single point of failure. And sorry, I see Victor here, but as we know, base went down today, so that's an example of why you wouldn't want a single point of failure in many cases. But I would say that we at Espresso, we actually think that the most important part of the rollup stack to decentralize is actually the sequencer. Because the fact that a single entity has control over the ordering of transactions gives them a lot of power that can potentially be abused. So for one, a central entity that knows that they will always be the decider, the final decider of the ordering of transactions, can rearrange transactions. They can decide to censor transactions or discriminate amongst transactions. And they know that they can set monopoly pricing or decide not to include transactions because they know that the next block and the next block and the next block, they will always be they will always be deciding that. So they can always maintain this monopoly. That is very dangerous. And decentralizing that, of course, helps solve that issue. And of course, allowing rollups to share the same sequencing infrastructure also gets some benefits, which I'm sure we'll get into as well.
Okay, so as for radios, I've been organizing a ZK research community called ZK Soul here since 2019. 2 years ago, I found MEV is kind of a really big issue because especially a harmful MEV, leads to financial losses on user side. So I thought that we could solve this problem with cryptography, not cryptoeconomics, because at that time there are many solutions about to use cryptoeconomics to solve this MEV problem. So that's the beginning of the radius. So recently we kind of pivoted to building sequencing layer with the same tech. So that's the beginning of our radius. So yeah, so let's get started about the main topic, sequencers, shared sequencers. But Charles, you already mentioned about something sequencers, but it's kind of technical. So I will get back to the basic questions because some of us here may not be familiar with the term sequencers or shared sequencers. So what's your definition of sequencers? Lisa?
I guess I gave a definition already.
Yeah, you gave a really good definition already. So I don't know if you want to expand on that, but I think when we're thinking about decentralization, it's more than just the sequencer. I think that's the part that we're focused on today, just like block production. But as a roll-up, when you're thinking about decentralization, block production is just part of it. You're also thinking about upgrades, like who can ultimately decide how the network works and how you go about upgrading it in the future if you want to. Whether it's like through social consensus or you can do it through a DAO vote. There's like a whole kind of spectrum of ways that you can upgrade the network. In addition to that, there's a lot of L2s or rollups that are thinking about decentralization of treasury management. So like actually enabling the community to decide how to allocate funds for the rollup. So those are examples of decentralization beyond block production, which is what we're going to be talking about today. But they're all super interlinked and complementary to one another. And so for us, we're thinking about all of those, but block production is probably the one that is most top of mind right now. Upgrades we're talking about actively as well, but because we want to launch decentralized with a decentralized sequencer, that's something that we're actively talking about and exploring with, as I mentioned, like folks like Espresso.
Want to add something?
Yeah, why don't you define?
Okay. Basically, sequencers just receive transactions from end users and then verify them and then build a block with those transactions and submit final states and some kind of proof on Ethereum. That's how these rollup sequencers works. And then personally, I think that the existence of this rollup makes the developers kind of hesitate to deploy their own rollup because rollup has kind of a scalability. Rollups can provide developers scalability and flexibility, but running of sequencers is kind of really hard. They should think of some kind of token economics, how they give incentive to run those sequencers. Those kind of really hard. So yeah, that's what I thought about the sequencers. But yeah, so Lisa, so the existing layer 2 rollups have right now centralized sequencers. So what are the considerations for layer 2s in decentralizing the sequencers?
Yeah, so as I mentioned, we are focused on the decentralization of the sequencer in part because we've gone about it in a more centralized way in the past. So before working on Aztec, the network, which is this fully programmable L2, we had a product called Aztec Connect that was not decentralized. We had a centralized sequencer. And what we realized is that it's really hard to decentralize something that's centralized because you make a lot of design decisions about how it works, assuming with certain assumptions if it's centralized. And trying to retrofit decentralization on it later is just was really difficult for us. And so that's why with this new network, we're kind of doing decentralization as the base assumption at the beginning. And so when we think about what is important to us from an L2, there's a whole spectrum of decisions that you have to make about your goals. And so think what you're optimizing for will determine how your design actually works. And so we talked about some of this before, but an example of this is considerations around latency and throughput. And if you want that, you might reduce the overall number of participants in the network just because you are optimizing for low latency or high throughput. On the other hand, if you want high participation, you might make decisions around what the hardware requirements are or how you'll coordinate across all these different actors that are running the infrastructure. And so I'd say that's kind of two of the axes that people are thinking about. It's how much participation do you want? How many actors do you want actually running the network? And like you said, a lot of L2s right now are focused on high throughput, low latency, and so they're opting for a single sequencer. And the way that they're decentralizing, despite having a shared sequencer, is through things like decentralizing the upgrade process and decentralizing decision-making around that. And so Arbitrum's a good example. They're running a single sequencer, but at the same time, if that single sequencer ends up being malicious or tampered with in some way, they have an upgrade mechanism so that the DAO can vote for a new sequencer. So that's kind of a protection mechanism, and it's not a single actor that can decide to upgrade the network. It's the DAO, and then they have kind of the security council as a backup. And so I think we're seeing in real time how rollups are balancing these two things, and it's really dependent on what their strategy is. And so what makes sense for Arbitrum, which is going for low latency, high throughput, doesn't necessarily make some sense for Aztec, which is looking for geographic diversification and many actors running the infrastructure. So we wouldn't have a single sequencer at mainnet launch.
How about Espresso? What's the shared sequencer is actually exactly solving?
Sorry, repeat that. What are shared sequencers?
Yeah, what is?
Yeah. So actually, why don't I respond to Lisa first? I think that's a great point. The fact that many users want high throughput and low latency, and that is currently something that only a centralized sequencer can provide. But hopefully, with the launch of Espresso, we can actually provide that in a decentralized manner. The way we do that is through Hotshot, as I mentioned. And Hotshot is really a consensus protocol that represents the other side of the CAP theorem. There's this law around consensus that protocol can only really be one of the two, the first being dynamic availability and the second being optimistic responsive. Ethereum, like Gasper provides what's called dynamic availability, which means that if the majority of the nodes go down, it can still maintain liveness, but it comes at the trade-off of having very slow finality. Actually, just as a tangent, I hear often people say, oh, Ethereum has like a 12-second finality. Well, that's actually a common misconception. That's actually not true. 12 seconds is like the block time of Ethereum. It actually takes around 15 minutes to finalize Ethereum transaction. It takes 15 minutes for Casper FFG. So on the other hand, we have optimistic responsiveness, and that is what Hotshot provides. So what we are targeting is to be able to have a decentralized network that can scale to tens of thousands of nodes, while also providing very, very fast finality, as fast as the network allows. And also what we mean by responsiveness is that the network can produce blocks and finalize transactions as fast as the network allows. So in optimistic conditions, when say you have a very good network topology with a very, very fast, highly connected central node, like running a CDN, you can finalize data very, very quickly, but it's also robust in worse conditions where you have a very sparse network topology. So yeah, that is really what we're optimizing for with Hotshot. And of course, Hotshot comes with disadvantages too. It requires higher trust assumptions, so we require that 2/3 of the stake is honest. But these are exactly the types of trade-offs that rollups and their users are making. Now to follow on to AJ's question about why a rollup might want to participate in a shared sequencer, as I mentioned earlier, a shared sequencer can provide a lot of benefits, a lot of advantages for interoperability, for bridging. It doesn't solve all the concerns, but it does address a lot of these concerns. So for instance, a very common use case is to want to bridge an asset or to have an atomic transaction across two rollups. So as an example, a user might want to transfer like an in-game asset on a gaming rollup, like some gaming item, and at the same time, they might want to receive a payment in Ether on another rollup, like say Arbitrum. And the user wants those two transactions to happen at the same time. The user doesn't want one of them to go through and not the other, because then one party would be getting scammed, basically. So what a shared sequencer can do is, a shared sequencer can guarantee that the two transactions on both rollups are included at the same time, and they're only included together. Now the problem is that inclusion is not the same thing as execution, because one of the transactions may be invalid. For instance, the optimism transfer may not be valid because the user doesn't have that balance. And in the model of a stateless sequencer that doesn't look at the contents of transactions, that cannot be solved. But with combining that with proposer-builder separation and some economic bonding from a builder, we can actually solve that issue. So as I mentioned, having a shared infrastructure for sequencing can make a lot of these interoperability challenges easier, but it isn't a silver bullet. It doesn't solve everything. One final thing I'll say is that having shared sequencing also reduces the possibility for some types of attacks, some types of security concerns. One very common attack when bridging is to, when you bridge, you lock an asset up on rollup A, and then you prove that to rollup B, and then and then rollup B mints an asset that represents the asset on rollup A that's been locked up. And one class of attack is to, of course, lock it on rollup A, and then mint it on rollup B, and then revert the transaction on rollup A. Now, if you think about it, that class of attack can be prevented, just because if two rollups are sharing the same infrastructure, then both would have to be reverted. Once again, this doesn't solve everything, but it does solve some things, and we've written an article about it.
So as for Radius, the problem we are trying to solve is that we think that sequencers have too much power, to extract values from the user side, and then whatever they want, they can do that. So we need to disempower the centralized sequencers. So the problem that these centralized sequencers can have like a harmful MEV to happening on the user side. So that's the one thing that we should provide as a protection for user side. And another one is that there is a huge amount of cost related to running sequencers. So MEV is not just a bad thing, but we can use this MEV to make some profit for rollups. So the thing that Radius is trying to do is that we want to make building a block efficiently, so we can make we can generate profits for rollups, so they can have their network as sustainable as possible in economical way. So those two things that Radius is trying to achieve using shared sequences, and also interoperability that Charles just mentioned is that really important issue in rollup space, because even though rollup is kind of have really great advantages, there are some criticism that there are like liquidation, fragmentation, and interoperability between the other rollups. So I totally agree with the view that Charles mentioned, that shared sequences is not the perfect solution to solve all the problems that rollup has, but it's possible to solve some of them perfectly. So that's some problem that Radius also are trying to solve. So let's talk about the progress that you've made. So I know that Aztec has decided to do the request for proposal about the decentralization sequences. So how did it go? And do you have any valuable insight from those process?
Yeah, so we decided to do a request for proposal, not only for sequencer selection, but also for things like upgrade proposals, treasury management. And the whole ethos behind it is that we know community building takes time. It's not going to happen overnight. And so we're starting at the very beginning of the designing of this network. So we want to not only build community sway by sharing ideas and learning from others, but also trying to find ways to partner with potential companies that are kind of at the bleeding edge of these topics. And so Espresso is an example of that. They know far more about this topic than any individual at Aztec can, because we're kind of focused on our one lane. And obviously we're going to know enough about sequencer selection, but there's some things that just are so bleeding edge that we can't possibly keep up with it as it's updating so quickly. And so the request for proposal process has been really great, because we've been able to get, I think there were 10 submissions total, some of which came from our team, some came from external teams. And because we brought in external teams, our team internally was able to build off of that. And so one of the ones that we're considering is called for net, and it was actually based off of a submission from the Espresso team. And so I think we're going to talk a little bit more about kind of MEV and censorship later on in the discussion. But one of the really interesting things that we saw was just that being kind of a decision point or differentiation across the different submissions of whether or not to enshrine MEV into the protocol, which is not something that I think many people are talking about right now. It's kind of, as I mentioned, bleeding edge of PBS research. And so yeah, I think the RFP process has been just really great from a community building perspective, learning from others and seeing what's gone well for others, what's gone poorly for others, and how we can make sure that to not make kind of those mistakes, but then also to just make our understanding of bleeding edge topics more robust, and then potentially build off of that internally.
So on the other hand, Charles, what value does the shared sequencer give to rollups? Why should rollups choose shared sequencers over running their own sequences?
Yeah, so I think to add on to the explanation I gave a little bit earlier about why it makes certain types of interoperability easier and why it makes certain classes of security more, attacks more difficult, I would say that a lot of the reason has to do with decentralization. And Lisa gave a really great example, and I think Aztec is a really great model for a decentralization process done right. Big shout out to Cooper on Aztec's team. I think Aztec is really the only rollup that I've seen that is committed to a really thorough process to decentralization of all parts of the stack, not just an ad hoc approach. So super impressive. As Lisa mentioned, we participated in the sequencer RFP. We submitted a proposal called Espresso Martini, I believe, that adds a layer that provides pre-confirmations to any Aztec transaction, which I believe none of the other models provide for decentralized sequencing so far. Of course, going back to one of the themes of this discussion is that each rollup, there's a big design space for sequencing. Each rollup has different things they're optimizing for. For instance, some rollups are optimizing for very fast finality and very, very high throughput. That is not something that Aztec is optimizing for, but what we did submit, Espresso Martini, is a layer on top that is compatible with any of the other sequencing approaches that can provide that. So yeah, overall, I think, first of all, for the reasons I mentioned before, decentralizing the sequencer, I think, is the role that is most key to decentralize because of the potential for abuse. And that with those powers of ordering transactions and censoring transactions. And I think the advantages of multiple rollups sharing the same sequencing layer and all the interoperability benefits it provides is actually just a cherry on top. It's a nice added benefit.
Okay. So, Lisa, you just mentioned about MEV. So I'd like to talk about this MEV and censorship thing. So as for Radius, actually this censorship and MEV problem have been around it quite long. So as for Radius, we use encrypted mempool. So basically, we encrypt transactions. So no one, including sequencers or MEV searchers, can look at your transactions. So they cannot manipulate the order of transactions. That's how we prevent this MEV thing as well. And then also, we applied a ZK to prove that these encrypted transactions are valid without decrypting them. So that's how we prevent MEV and also censoring. But how about the shared sequencers and decentralized sequencers? Do you think that those kind of approaches help to minimize those attacks?
Yeah, sure, I can take that. So first of all, I think what Radius is doing is very interesting, and I also think it's very complementary to what Espresso is doing, because I think while Radius is very focused on MEV mitigation through cryptographic techniques, Espresso is trying to take a neutral approach to MEV, and our plan is to allow rollups to take whichever approach to MEV they feel is appropriate, whether that be something akin to first come, first serve, or whether it be time boost, which was proposed by Arbitrum, or whether it be some more MEV maximization scheme where the profits are passed to the rollup users. So that is what we envision, and I think a decentralized protocol for sequencing helps create the conditions and make the incentives such that operators of the sequencer nodes have an incentive to behave honestly in a way that a centralized sequencer would not. Because in a decentralized sequencer model where a sequencer node knows that it's only going to be a sequencer for a short time, perhaps only one block or a few blocks, they know that they need to behave myopically, which means that they need to maximize their revenues from fees in the short term. Unlike a centralized sequencer, which knows, like I mentioned before, they're going to be the sequencer forever, and they will always be able to censor transactions from a certain party or discriminate and have very high pricing for fees from a certain user. Of course, there are escape hatches that some rollups have implemented on the L1. But if you imagine a world where there's thousands of rollups, it might be prohibitively expensive to submit to the L1 directly. So anyways, back to the point. I think I've gone a little over time, but yeah, definitely lots of design, lots of choices in the design space, and I definitely think everything that we're doing here is very complementary.
Yeah, the only other thing I'd mention is that we, as I mentioned, we had like a bunch of different proposals. Some of them are more kind of like selecting a sequencer randomly, and then the others that have enshrined MEV were more economically focused. And so there are, like I said, we're not probably going to pursue that because it's so bleeding edge as like the first design, but we can potentially implement that in a future upgrade of the network. But there are interesting ways to kind of like embed MEV into like the way the protocol actually works, where you have an auction to determine which sequencer's block is actually going to be selected. So I think that there's going to be different approaches to MEV, whether it's like directly in the protocol or partnering with something like Radius in order to do that.
Okay, so last but not least, pleased to share that what do you think your role in blockchain space? It's our last questions.
I'd say bringing privacy to Ethereum. That's like the highest calling for us. So.
Yeah, just as a one-liner, I think just providing one part of the sequencing space that we believe users care about the most, which is having good guarantees around transaction ordering and allowing rollups to make much of that decision while providing the key properties like fast finality to users.
As for Radius, we'd like to support a sustainable ecosystem because blockchain is all about giving incentive to all participants. So we'd like to help these developers, users, and even sequencers so they can run this blockchain network sustainable as possible. So thanks so much. So it's time's up. So please give a big applause to these panelists. Thank you so much.
All right, thank you.